Hello again. So today I've got a board that I'm working on. It's a 2012 15-inch Macbook Pro. The model number is 8203330. A couple things to mention about this board. If you are having issues with your 2011 MacBook Pro with the GPU failure, which a lot of people are, this is probably one of our most common repairs. We get so many of these in a week, probably over 30 a week for GPU replacements. And this is not uncommon. This is a very, very common issue with these 2011 MacBook Pro boards. If you are not wanting to deal with that anymore, you can actually, through a little process, upgrade your 2011 machine with a 2012 MacBook Pro board. The only issue is that's going to be a little different is your display connector. It's a different type of display cable that you're going to have to either buy a different display or install a different display cable onto your display so that that will be compatible with this board. This board does not have any issues with the GPU failing. And very rarely, I mean, I think I've had one where the GPU failed, and it actually was the only one, I believe, out of the many years that I've been doing this type of work. Anyways, that is an option that you can do anyways. You can look into doing that. However, this board right here is not getting any power to it. And I'll show you real quick. Let me get the camera adjusted here so you can see. Now, we'll take the charger, plug it in, and you'll see that there's no light coming on the adapter. It's not turned on at all. So the board is not getting any power to it. Now, when you have this type of issue where you're not getting any light on your adapter, one of the first things you should check for, one of the first power rails, is your 3.42 power rail. And I'll show you on the schematics here. Let me go ahead and pull that up. You can look for the one wire circuit. And so, let me see here. Get the schematics pulled up. Here we go. Alright, and so I'm just going to do a search of the schematic here for a one wire. And I think that's how it puts it in the schematics here, is just one dash wire. Yeah, so your one wire over voltage protection. And you can see here that this comes from your MagSafe DC power jack. And so you have your voltage coming in, but first, before that turns on, you have to have your power or adapter sense. And it goes through this little chip here, the U6900, which has your system one wire. It's a bidirectional line, as you see here. And this goes to and from the system, which goes to your SMC. Now also you have your SMC BC AC OK, which comes from your SMC as well. And this is talking to your machine to let the adapter know, hey, you are good to send your voltage in to power up the machine. So right now we're not getting anything. And the reason could be is because we're not getting our basic 3.42 power voltage. And I'll show you that. Whoa, didn't mean to do that. Right here, your 3.42 G3 hot power supply. And so this is what talks to your DC in as well, and your battery. And if you're not getting 3.42, you're not going to get any voltage to come in from your full voltage from the adapter. And so let's go ahead and check. Let's see, right here we can check this L6995. Let me go ahead and pull up the board view of this. This is the 8203330. That pulled up. Man, it's taking some time this morning. Excuse me. Been a little sick, so having to get the work Alright, we got the board view pulled up now. Yeah, we're good. Okay. So, we're looking at the L6995. Let's go ahead and type that in. L6995. And where are we located here? Right here. And this is a coil. And see if it's located in this area right here, close to where the battery plugs in. And so what I'm going to do is I'm going to check and see if we have any voltage on either side of that chip, because this is going to be what is sending. It's going to have the power coming from your U6990, which is putting out the 3.42 volts, and it's going to show if it's going to the system. So let's go ahead and get this. Let me get a better view here for you. See if I can get a good view here for you. It's going to take me a moment to situate this. Alright, now let me get over to the microscope view. Get you in focus. Alright, so right here, this says 333 or 330 on it. We're going to check our power on that and see if we are getting 3.42 volts. Okay, so on this side, no, we're getting 1.47, and on this side, we're getting 1.67. Alright, so what I'm going to do is now I'm going to unplug the power from the board. And I'm just going to check and see if we have a short to ground. That's a low voltage going there. So put this over to diode mode. And we're going to check and see. Yeah, we have a 0.001002 drop to ground, or it's short to ground. So that's a pretty good short. So what I'm going to do is I'm going to remove this this coil now. And we're going to check it again and see which side has our short to ground on it. Excuse me. Okay. Let's see our coil right there. And now let's check and see which side is shorted to ground. On this side, yeah. Is it on this side? No. So on the bottom side, we have a short to ground. Now let's jump back over to our board view. And this is where we have our short to ground here. It's on pin 2. So our pin 2 is what goes to the rest of the system. As you can see from the schematics, right here, here's our coil. We have 1 and 2. Here's pin 2, and this is what's going to the rest of the system, not what's coming from our supply. So what we're going to do now is get the camera back on me here. What we're going to do now is I'm going to take my power supply. I'm going to turn on 3.42 volts from my power supply, and I'm going to hook up my wires to the board. Your black one on ground, your red one on the second pin on that coil, and I'm going to inject 3.42 volts. Now, whatever is shorted to ground, whatever component in the rest of the unit is shorted to ground, is going to begin to get hot, because that's going to have a lot of current going through it, a lot of amps. And so when you get a lot of current, a lot of amps, that unit or that chip is going to get hot in that area. So we're going to know exactly what component is shorted to ground. So I'm going to go ahead and get that hooked up now. And let me get the camera angle again so you can watch me do that. First, Let's see if can you see my power supply here. Get a full screen. Alright, so here's my power supply. I'm not going to be able to angle it exactly how I need to. Alright, so I'm going to turn it to 3.42 volts. 3.4. Alright, so 3.4 volts. That's what I have that at. And so now I'm going to turn it back off. Now I'm going to solder on the black lead onto ground, which you can just do like a screw hole here that has the excuse me, the copper padding around it. And that is going to be your ground. So I'm going to add a little bit of flux to the area. I'll go ahead and pull these RAM chips out as well, just to avoid possible overheating those. Solder that onto the ground plane, like that. And now I'm going to add a little bit of flux and solder to that second pin there. That we have our ground, or short to ground on. And now I'm going to solder on the red wire onto that pad. Alright, nice and solid. And now I'm going to turn it on, and it says we have 0.9 amps going through. So oddly enough, I mean, that's not much. We're still pushing out 3.5 volts. With low amperage. We're not even getting 1 amp. Now we're getting 1 amp. It's jumping around. So I'm just going to fill around on the board. See if I can feel anything overheating. It's still hot in this area, but it might be because I soldered the board right there. Possibly. That's pretty hot. Alright, what I'm going to do is I'm going to get a clean rag. Okay, I'm going to put some alcohol on my rag here. I'm going to get you back over to the microscope view, and we're going to look at this area close up, because it is getting hot in this area. So it's drying up pretty fast, but it may not be because it's on the top. Let's check out on the bottom of the board. Oh, you see that? So our SMC is what's heating up right there. Got a lot of heat coming from our SMC. So, unfortunately, we have a bad SMC, so we're going to replace that. So I'm going to go ahead and do that. I'm going to go ahead and get this SMC pulled off, and we'll reball another SMC, and go ahead and turn my power off to my supply, and we'll unfortunately have to reball an SMC. So I'm not too excited about that. It's not a fun repair. But I'm going to go ahead and get this one pulled off. And after I pull this off, we'll check for a short to ground again. To see if our short to ground has been removed. Take a look on the bottom side here, and it does look like it's been liquid damaged. It's had some kind of liquid in there. besides the alcohol that I rubbed on it. So this chip has been damaged. Alright, so I'm going to go ahead and clean up the board. And we will reball a new GPU, or a new SMC. Go ahead and clean up the pads on the board here. Alright, so before we move any further, let's check and see if we have a short to ground still. I know we have to remove these wires from the board that we put on there. And let's check with our multimeter. You see that? Yeah. See if we have a short to ground after removing the SMC. Yeah, our short to ground has been removed. So you see it's climbing up there. So our SMC was the problem. That kind of confirms it. So I'm going to go ahead and get another SMC removed from another board. Alright, so I have the chip off finally. It took me 3 different boards to get a good SMC. And so hopefully this one is good. By the time I install it, hopefully it works. But I was going to show you a new way that I reball the SMC. And I saw someone else do this, and I thought I would try it myself. And sure enough, it works really well. And it's a lot easier. It takes a lot less tape and prepping down, as you've probably seen. You may have seen in my other SMC replacement video. In this method, anyways, you replace, or you get a layer of paper towels, and you fold it up and you paste your chip on it. Then you place your stencil on top of that, and then we're just going to get our solder paste, and I'm going to get a tool to spread that on with. See, this should work okay. And so what I'm going to do is just place my tweezers right in the middle of the chip there to hold it in place. And I'm going to get some solder paste on the end of this tool, and I'm going to rub it in. Just spread the solder paste on like so. Side down really well, and then we're going to come back and do this other side. Okay, now let's kind of let's get another flat tool. If I have one that's over here and I can kind of clean up. Scrape off all the extra. It doesn't have to be perfect, but because when we reflow this, it's going to float into place. Alright, so now we're going to take our hot air and we're going to just put our tweezers right in the middle here to hold it in place, and we're going to just slowly heat that up. Starts to bubble up a little bit, we're going to press it down a little bit, even it out so it doesn't combine with any of the other solder balls. So I'm going to lower the air a lot on this, because it might just be too much air. see every now and then a few of these solder balls want to jump out. So you've got to let them dry. And then just push them back down in there. Like so. Alright, I believe all of them are in place now. Excuse me. And we'll let that dry. Okay, looks like they're all dried. And we're going to flip it over. And the reason that they said to use the paper towel method is because if you put it right on the metal table is going to absorb all the heat really fast. So it's going to take a lot longer for those solder balls to melt. And if you're doing this, it does burn the paper towel a little bit around the edge, but if you're doing this, then you're allowing the heat, the chip to take all the heat, and it reflows that solder a lot faster. So it's a pretty neat method, and it seems to work really well. So I'm going to go ahead and soak this in alcohol for just a second. And then going to pry this chip off. A little bit more alcohol. There's our chip, and I'm going to go ahead and hit it real quick with a little bit more heat to reflow those solder balls nice and even. And all that bubbly stuff in there is flux. I'm going to clean all that off, so don't worry. Better hold it with some tweezers. All those solder balls look nice and even. Should be all good. Okay, I'm going to take this over to the Ultrasonic Cleaner real quick and clean this chip up, and I'll be right back. Alright, so we have our chip that we've reballed, and we're going to put it onto our board and replace that SMC and see if we have any power to our board. So hopefully, fingers crossed. Alright, it's going down. We'll go back to the microscope view. Alright, so let's add a little bit of flux. Nice and even. And then we're going to place our chip in place. And I'll kind of show you how we get this set ready to put on and make sure we're straight. What I like to do is line up a line of or a row of pads evenly with the chip, and then simply walk it over until you feel the pads on the bottom of the chip. Rub over those set of pads. Right there, I can feel the pads. a little bit of time to get it lined up right. It's very important that you do, or else you're going to be doing this whole process over again. Alright, right there, I can feel it. Alright, I'm going to heat up the chip. Going to add a little extra flux to make sure it floats into place correctly. And once it melts, you'll see it move. See it move right into place? Dancing around. That's how you know that it's like all the pads are connected there. So now we'll let that dry for just a minute, cool down, and then I'll clean it up and we'll check and see if we have power. One more thing, I have to put this coil back on as well, which I did not put back on from earlier. So we're going to get that on. Turn up my airflow. Alright. So let's see if we have power to this thing. A green light. Let's see if we get a fan spinning. Alright, did we get a fan spin? Yes, we do. So we have the board now powering on, and looks like it just ended up being the SMC, which was quite a journey in replacing that. So anyways, I'm going to get this installed back into the board, or into the unit. We'll power it on and see if we get a display, and I'll be right back. Okay, so I have the board plugged back into the unit. I don't have it screwed down or anything, I just have everything plugged in. It's kind of like what we need to do, just in case there is something else going on with it. So we'll have to take all the screws back out again. So I'm going to plug in the power adapter and see if we get power, which we do. And we have a display. And I think this hard drive in there is empty. So I'm going to take my test drive and see if we can get this thing to start to boot. There we go, select my drive, and we have power. The unit is powering on. It looks like it's working properly. So we have fixed the issue. The issue was that the board was short of the ground. The 3.42 volt voltage was not getting produced because it was short of the ground. And the reason why is because the SMC was what was causing the short to ground. So we removed the SMC, replaced it, reballed another one, got another one installed, and so this board is now good to go. A little long of a process, a little frustrating at times because removing that chip from another board easily can damage it. Reballing it, these chips on these SMCs are easily damaged, and also after you get all of that completed and the chip installed, you're just hoping that you get a good SMC to install back on the board, because you can't buy these chips new. They're programmable chips. Apple's the only one that can program them, and unfortunately the only way to get these chips is to remove them from scrap boards. So anyways, we have this machine back up and running, and we're good to go, and hope that you were able to learn something from this. Hope it was informative and fun, and until next time, take care, and we'll talk to you later.